Have you ever wondered why a basketball follows a smooth curve when you shoot it, or to calculate how far a rocket will travel before hitting the ground? That curve is called parabolic motion. In this lesson, we'll break it down step by step, how to find the time of flight, the maximum height, and the range of the projectile. By the end of the lesson, you should be able to solve similar problems on your own. With projectile motion, an object has velocity in two separate directions. In this example, we have a velocity going vertically along the y-axis. We also have velocity going along the x-axis. We'll say this is v sub x for velocity along the x-axis. Now, the velocity along the x-axis will be constant throughout the entire period, while the velocity along the y-axis will begin to slow down and then stop at the apex. At the apex, the velocity along the y-axis is equal to 0. Then it will again accelerate as it's going downward towards the ground on the other side. So to get started, velocity along the y-axis is equal to the velocity of the object times sine theta, where theta is the angle in which it was projected. Velocity along the x-axis is equal to velocity times the cosine of theta. In this video, we're going to assume that the object starts and stops at the same height, or like y equals 0. We know that at the top, the velocity is 0 for the y. So we can say that the velocity y for the final is to velocity y initial plus gravity times time. This is 0 at the apex. So that's going to equal then v times sine theta plus gt. Okay, let's take the gt to the other side. Velocity times sine theta. Divide both sides by g. Now we're going to ignore this negative g here because actually gravity will be negative 9.8. So we can say then that time is equal to velocity times sine theta divided by g. Now this is for half of the flight. So it's going to take the same amount of time going up as it does going down because gravity is still acting. So I'm going to multiply this times 2. So to clean this up a little bit, we'll say then that time is equal to 2 times velocity times sine theta divided by g. All right. There is another way of solving this, which is more universal than this formula. So let me show you that way. We could say that y equals the initial y plus velocity y initial times time plus 1/2 gt squared. That means if it starts at a height above the ground. But in our case, we're going to let it start from the ground. So I can say y here is going to be 0 because it's going to start from the ground and end at the ground. So y equals 0. Then velocity times the sine of theta times t plus 1/2 gt squared. I'm going to bring the 1/2 gt squared to the other side. Now let's multiply both sides by 2. Divide both sides by g. So t squared equals 2 times v times sine theta times t divided by g. Let's divide both sides by t. So t is equal to 2 times v times sine theta. As t cancels over g. So that's basically the same formula we had before, but here I'm showing you how you can solve it where it doesn't land, but rather it's just a partial parabola instead of the entire thing. All right, how do I find range? So we want to know how far does it travel horizontally. We know that its velocity is constant horizontally, so my x, or my range, is equal to the velocity along the x-axis times the time. So x is going to equal the velocity times the cosine of theta times t. Okay, let's go ahead and substitute there. So we can say then that x is equal to velocity times cosine theta. We said earlier that the time was 2 times the velocity times the sine of theta divided by g. We will have x is equal to velocity squared times 2 times the cosine of theta times the sine of theta. Okay, here we need to use the double angle formula. It says that the sine of 2 theta is equal to 2 sine theta times the cosine of theta. All right, so we're basically going to use this so that this part here will be equal to sine of 2 theta. All right, so all of this is going to equal this. So I can say that x is equal to v squared sine of 2 theta over g. Okay, that will be the range, or how far along the x-axis that it will travel. To calculate the maximum height, we're going to use the formula that says that the final velocity along the y-axis squared equals the initial velocity along the y-axis squared plus 2gy. Now we know that the final velocity is equal to 0 when it's at the apex. So we're going to set this equal to 0. All right, so this is going to equal v times the sine of theta. I'm going to square that plus 2gy. So let's take that to the other side so that 2gy is equal to v times sine of theta. I'm going to ignore the negative sign here because gravity is going to be negative. So we're just going to ignore that. I'm going to divide both sides here. I'm solving for y. I'm going to divide by 2g. So this will be our formula. The maximum height, or y, is equal to V times the sine of theta squared divided by 2G. So to summarize our formulas, we have time is equal to 2 times V sine theta divided by G. We have range is equal to V squared sine 2 theta divided by G. And we have the maximum height is equal to V sine theta squared divided by 2G. In our first example, we have a projectile launched at 20 meters per second at an angle of 37 degrees. Let's find the time in the air, the range, and the height. So time is going to equal 2 times V sine theta over G. So the time is going to equal 2 times 20 times the sine of 37 divided by 9.8. So that gives me a time of 2.46 seconds. Okay, range. So range is going to equal V times cosine theta times t. So range is going to equal 20 times the cosine of 37 times t, which was 2.46 seconds. That gives me a range of 39.2 meters. Okay, the height. So the height is going to be V times the sine theta squared over 2G. So that's going to equal 20 times the sine of 37 squared divided by 2 times 9.8. So the height here is going to equal 7.39 meters. In this example, we have a projectile being launched at 100 meters per second at some unknown angle. And it has a range equal to 70 meters. So we'll be solving for theta here. Okay, these are a little more difficult here when you're solving for an angle. So I have range is equal to V times the cosine theta times the time. So the range is 70. It's equal to 100 times the cosine of unknown angle theta times time, which is 2 times 100 times the sine of theta over 9.8. Okay, let's cross multiply by 9.8. So I have 70 times 9.8 is equal to 100 cosine theta times 200 all right, so this is equal to 686 is equal to 100 cosine theta times 200 sine theta. Let's divide by both 100 and 200. So this would give me 0.0343 equals the sine theta times cosine theta. Again, we're going to use this double angle identity. And the double angle identity says that the sine of 2 theta is equal to 2 sine theta times cosine theta. Okay, I'm going to take this 2 to the other side, so it'll be 1/2 the sine of 2 theta equals the sine theta times cosine theta. So we have 0.0343 is going to equal 1/2 the sine of 2 theta. Let's multiply both sides by 2. So by multiplying both sides by 2 here, I would get 0.0686 equals the sine of 2 theta. Okay, so I need to find the arc sine, 0.0686, and I'm going to divide this by 2. That will equal theta. So theta will equal 2 degrees. So that would be my angle. In this example, we have a football player kicking the ball at 20 meters per second at an angle of 37 degrees. He's 36 meters away from the post. The crossbar on the goalpost is 3 meters high. So will the ball make it between the crossbars? Okay, so let's start off by finding the y velocity. Okay, so velocity along the y will be 20 times the sine of 37. So the y velocity will be equal to 12 meters per second. The velocity along the x-axis will be 20 times the cosine of 37 degrees. So velocity along the x will be 15.97-ish. So we're going to round that off to 16 meters per second to make life a little easier here. Okay. So we know that time is equal to the x distance divided by the x velocity. For time, it's going to be 36 divided by 16. So that means 2.25 seconds is the time it takes for the ball to reach the goalpost. And we got that again from calculating our horizontal velocity. Now let's see if it has the proper height. So y is going to equal y sub o plus the velocity along the y initially times time plus 1/2 gt squared. So he kicked it from the ground, so we can ignore that y sub o. So we're going to solve for y. Y is equal to the initial velocity along the y, which is 12, times my time, which is 2.25 seconds, plus negative 4.9 t squared. When I calculate y, I get 2.2 meters. So it's below the crossbar. So he does not make the field goal. If this video helped you out, make sure to give it a like and subscribe. Thanks for watching, and I'll see you in the next one. Goodbye.